This assignment required you to use statistical process control and specifically the X bar and the R chart and compare two shifts and first of all look at the two shifts that are being used to fill bags of cereal in a particular line and see what's going on there in terms of the two shifts, whether there's a difference between the two shifts, as well as to check what is the capability of the process if the process is in statistical control during these two shifts. So that was pretty much the question that you were asked, and the details that you were given were that these are supposed to be 500-gram bags of cereal. These are filled using an automatic pourer, and there's the bags are also included in weighing. So in order to make sure that to keep the variation in the bag weight out of the equation, the quality control manager started to check based on tearing the bags and checking the weight of the cereal inside the bags to see whether it was 500 grams. And he has collected data from the filling process over 5 days. So there are two shifts, and he has collected data over 5 days, and each day he has collected data at 5 different times, and each of those times there are 10 bags. And that's the information that you're given in terms of the frequency of a sampling and the sample size. So his sample size is 10 bags every time he takes a sample. What he has done is he has done some of the work for you. He has provided you with the sample averages, and he has provided you with the smallest and the largest value in each of those samples. So the averages for each of the samples has already been calculated, as well as the smallest and the largest. And once you have the smallest and the largest, the range can be calculated. The question that's being asked is based on the data that's given to you, check whether the process is in statistical control, computing the limits for both the X bar and the R charts for shift 1 and shift 2 separately, and compare the sample averages and ranges that you have from all of the samples to see whether each of these shifts the process is in statistical control or not. And you were asked you're not required to draw the control charts, although if you wanted to get more insight into any kind of trend, you would be drawing the control charts as well. The second part of the question was, what can you say? Once you have these results from doing the statistical process control analysis, doing the SPC analysis, what can you say? Because you're also told that there is some kind of a hunch that the second shift has a particular issue in terms of underfilled bags. So what can you say about that, whether that is a hunch that's being supported or not being supported based on the data and based on the analysis that you can do using SPC. So let's go ahead and see what we can find based on the calculations that we can do for the control charts. So first of all, although in the problem statement you're given just the partially converted data into averages and the maximum and the minimum to give you a shortcut. What you're also given is the Excel spreadsheet with the complete data. So if you wanted to get practice into what would the complete data set look like, and then be able to calculate the averages and calculate from that the control limits, and even practicing drawing the control charts, you could possibly do that as well based on the data that's provided to you in addition to what's being provided in the problem. All right, so let's start with shift 1, and let's start with the range chart for shift 1. So if you remember from statistical process control, when you're talking about continuous distribution charts, measurement charts, they always go in pairs. So we're going to compute the R and the X chart. We do the R chart first because the R is going to be used. The average range is going to be used in order to compute the upper and the lower control limits of the X bar chart. So if the range chart already tells you that there's something that's out of control, then we might have to eliminate that and recompute the range before we go to the X bar chart. So that's why we typically do the R chart first. Although when you do this using software, it's just going to quickly run both of them. It's not going to tell you that one is not in control, and therefore you shouldn't be calculating the other. So that's something that you need to keep an eye on in terms of both the R chart and the X bar chart should give you results of it being in statistical control, if that's the result you're looking for. Right, so let's take a look at the range chart for shift 1. The center line is going to be based on the mean of the ranges. The ranges are calculated by max minus min. Max and min are given to you, smallest and largest values. The upper control limit is going to be based on taking that mean range and multiplying by the D4 value, and the lower control limit is going to be based on taking that mean range of 34.6s and multiplying by the D3 value. So that's 1.77 is the D4 value, and 0.223 is the D3 value. And what you get as the upper and the lower control limits are 61.59 and 7.73. So you may recall where these D3 and D4 values come from. It's from this chart that we had seen when we talked about statistical process control. And you can see that because we have a sample size of 10, so we're taking the table that's on your right, and we're taking the first row from that with a sample size of 10. We're using the D3 and D4 value. And this is where you will also get the A2 value that you're going to use for the X bar chart. So make a note of that as we go forward. All right, so coming back to the R chart that we've calculated for shift 1, what can you say from this R chart? Well, you go back to all of the range values that you have calculated for the 25 samples for shift 1, and what you'll see is that all of the values that you have there in terms of the range fall within 7.73 and 61.6. So the cereal bag weights are expected to vary by between 7.73 grams and 61.6 grams. So there's going to be, if this process works as it is working right now, and everything stays in statistical control as it is right now, you can expect there to be variation between 7.73 and 61.6 grams from this process. And that seems to be a little bit high when you're aiming for a 500-gram bag, and that it can be varying by this much. However, we still need to look at the X bar chart to see how much short or how much higher it's going to be compared to the 500-gram target that we have. All right, so let's take a look at the X chart or the X bar chart for shift 1. So we get the center line, which is based on taking the 25 means, the means of the 25 samples. So we get the mean of means, or the X double bar of 500.2244 for shift 1. The upper control limit is based on taking that mean and adding 0.308, which is the A2 value which we got from that chart based on a sample size of 10, and multiplying that by the average range that we got when we did the range chart. So we take that, we get an upper control limit of 510.9. We take a look at the lower control limit, and that works out to 489.55. So what are we saying here? We're saying that the upper and lower control limits are 489.55 and 510.9. So first thing we need to do is, because we are calibrating this control chart, we're calibrating the upper and the lower control limits, we need to check whether this calibration is going to work, and for that we go back and we look at the 25 means, and what you'll find is that those means fall within these two limits, between the lower and the upper control limit. So the averages of all 25 samples fall within these control limits. So we can go ahead and state something about the inherent capability, inherent potential of this process, and we can say that cereal bags are expected to weigh between 490 and 511 grams, if you were to round up, 490 and 511 grams. What you can note from here is that although everything is in statistical control, the center line for this chart was 500.22 grams. So in a sense, what this is telling us is that there will be 50% of the output from shift 1 that is going to fall below 500.22 grams. So there will be underweight bags coming from shift 1 in terms of weighing those bags and checking what the weight of those bags is. So why it's happening, we don't know, but there seems to be a propensity for underweight bags from this shift as well. Now, let's take a look at shift 2, because if you remember, there was a hunch about shift 2 being the culprit behind this whole thing. So let's take a look at shift 2. But before we do that, although you weren't asked to come up with the charts for these bags, here are the charts that that you would have come up with, and I came up with these using Minitab, and these confirm what we found earlier, that all of the points are within the upper and lower control limits, and the control limits are what we had found for the R and the X chart. Right? So given the data that you have, you can actually go ahead and compute these charts if you have access to software such as Minitab or any other software that can be used to compute control charts. All right, now let's take a look at shift 2, right? So we're looking at the second shift here, and again we start with the range chart. Similar process that we had earlier. We get the center line 34.49, we get the upper control limit of 61.29, and the lower control limit of 7.69. So our control limits are going to be 7.69 and 61.29. And the first thing that we need to check, or the first thing that you would want to check, is go back and look at all of the ranges, the 25 ranges that you have for second shift, and do they fall between these two? And what you'll find is that they do. So we can take these control limits and depend on them. We can say that given the way that the process is currently performing, we can say that there's going to be a range of between 7.69 and 61.29 grams. There's going to be variation between 7.69 and 61.29 grams. Very similar, if you remember, from shift 1, right? So this range is very similar. So in that sense, we can say that there's not much difference between shift 1 and shift 2 when you look at the range and the control charts for the range. So let's go ahead and move on to the X bar chart now for shift 2, right? So here we get a center line of 481.8. So this should be giving you some cause for concern if you are thinking about 500 grams. So the center line itself is much lower than 500 grams. And when you look at the upper control limit, similar calculations as the previous one. We're using the range that we got from the second shift, and we're multiplying it by A2. The A2 remains the same as shift 1 because everywhere we had samples of size 10. So we're staying with that same A2 number. But you can see that the upper control limit is 492. Again, there should be alarm bells ringing in your mind, because the upper control limit is telling you that even if this process isn't statistical control, it's not going to give us output that is greater than 492, which itself is less than 500. You look at the lower control limit, and that's 471.17. Now, the first thing that you need to do is check whether all of the means of those 25 samples that you had from shift 2 of size 10 are giving you values that fall between 471.17 and 492. And simply looking at that chart that was already prepared for you tells you that none of those means are outside these limits. So they are all between 471 and 492. So this is how the process would perform under usual circumstances, under the way that it's currently performing. And we can rely on it because nothing is out of statistical control, right? No points out of statistical control. However, we can also say that the cereal bags are expected to weigh between 471 grams and 492 grams, which tells you that all of the bags in the second shift are going to be less than 500 grams. The upper limit itself is 492 grams, so it's telling you that all of the bags are going to be less than the upper control limit. So putting the information that we got from shift 1 and shift 2 together, and given that they had a hunch about shift 2, what can we say about all this? Well, first let's take a look at the control charts that you would have got if you would actually compute the control charts. Again, giving us the same information that we had based on the calculations that we did. Once again, you were not asked to come up with these control charts, but it gives you a nice pictorial representation of how the data would look in terms of a control chart. And if you had more information as to what particular day things are going up or down, you can even think about that. But here, the main point is that you're aiming for bags to be at 500 grams, and even the upper control limit of the X chart is not reaching that level, let alone the average. The upper control limit is also not reaching that average. So it's telling you that most of the output from shift 2 is going to be underweight. So overall, the interpretation that we can get from this, and we've interpreted each of those shifts as we went along, but overall we can say that the ranges for the two shifts are similar, but they appear to be quite high. When you think about how much variation you're expecting from taking a sample of 10 bags, they appear to be quite high because you're getting an upper control limit of around 67, and that's quite high. Shift 2 is certainly worse than Shift 1 in terms of underfilling the bags, but Shift 1 is not doing very well either, because there the center line was at 500, so it's telling you that 50% of the bags would be under 500 grams. So yes, Shift 2 has a problem, but it's a bigger problem than Shift 1. Shift 1 also has a problem here.